Yesterday we have studied how to simplify the algebraic expression. We studied the like terms, unlike terms, and we studied if the denominator of the denominators of two fractions are more than two fractions are equal, then you can simply add the numerator and just put one denominator. And we studied these things, how these things happens. Open your notebook. Okay, today we will do one exercise, and those we will solve exercise 14.1, and we will solve some problems from that thing. Exercise 14.1. And the problem number 1, part A. Let me do part A. It is written that 2a plus 3a plus 5a. 2a plus 3a plus 5a. So, as these are like terms, understand? These are like terms. We will simply add the coefficients. We have studied this yesterday, how to deal with the like terms. So, 2 plus 3 is 5 and 5 plus 5 is 10. So, 10a is your required answer. It's very straightforward. I think there is no confusion. Let me do part E. 3e. 3e plus 8e plus 7 plus 7 and minus e. Abdullah Sagir, tell me how to do this, how to simplify this. No, Abdullah. Yeah. What are like terms in this?
3e plus 8.
Plus 3e and 8e. These are two like terms. And what about e? Is it a like term or not?
Sir.
Yeah.
Sir, it is. E means 1e. It means like it is.
Yeah, it is actually 1e.
Can I see the answer?
No, wait. Yeah, Abdul Hadi. What to do with this? There is one problem in this. The problem is this e is like terms with this and this, but this e is on the other side. So what to do first with this? How to solve this issue?
Sir.
Yeah.
So, what I'm supposed to say, like, first thing we plus the 3 by the 8, it will be,
Okay, Abdul Hadi, what to do with this? Yeah.
so the answer is 17.
Yeah. Okay, look here. I will do one thing.
And e plus 1.
This will become 11e plus 7 minus e. Now, can anyone please tell me how to shift this here? Because this is like terms, you can add like terms, but when they are together. Right now, they are this is here.
Sir, I have a question. Am I supposed to say we need to minus 1 from the 7, so it be 6?
No, this is not e. E is something, e may be 100. How you can subtract 1? It's not. Zikriya. You?
Sir,
Yeah?
can't we?
You don't know?
Sir, can't we simply, because 7 has like no variable on it, can't we simply minus it from the 8?
Yeah, we can't add 7 because 7 is not a like terms with this term. But this and this are like terms. But my question is how to bring this here so that we can add it or we can subtract it. Yeah, this is the main issue.
Sir, it's minus e, so you can put minus e there and plus 7.
So, okay, this is good, but why?
Because you have
Why you are allowed to do this thing?
Because 4e and 11e and e are like terms, that's why.
Look here, this is one number. E is, suppose E is 2. So this is 22. This is plus 7 and this is minus 2. So for a while, this will become 22, this will become plus 7 and this will become minus 2. Now these are numbers, okay? And numbers, one thing is very clear. What we are doing here and what we are doing here. Here you are dealing 22 and 7 first, then 2. And here you are dealing 22 and 2 first, then 7. So it's not a meter in the numbers, okay? At least it's not meter in the numbers. Maybe there is some mathematics where it matters, but in the numbers it doesn't matter. So you can flip numbers, okay? You can move or, yeah, the answer is same. This is very simple thing. This is really easy to say that the answer is same, so we are not troubling. So this will become 11e minus e plus 7. 10e plus 7. And this become our final answer. Understand? Now, I think all the other parts are very similar to this in problem 1. So we will go to problem 2. In problem 2, we have to write the algebraic expression for the perimeter of the different shapes. Let me do part B from 2. Okay, is it clear? Anyone have problem in this? Okay, you can remind from chapter 6 what we introduced this symbol. What is the meaning of this and this? No, why like one cross here or two cross? What's the difference? What is the meaning of this cross? Are these like this? What is the meaning of this thing? It is here, it is here. We have studied this thing. Yeah. Well,
Yes, I remember that. We know that. We know that when we come by here, and we have like missing numbers. When we have here like 3 and then nothing to do with it. We write here 3 because the same number of this is 3. It has to be the same here. Like
I think you are right. I didn't get your message exactly. Okay, thank you. Sit down. Look here. Suppose this side is given. It is 3. Okay. So you don't want to write 3 again and again. So use a symbol, and this one is the symbol of 3. Suppose. So use this symbol here. It will mean that this is also 3. And we have used it here. It means this is also 3. So this is, and this is B. So, and we have used this double like equality. Okay, we have used like the equality type of symbol. Okay, so on those places where you will see the equality type of symbol, it will represent that they all are exactly B, because we have introduced this type of symbol for B. Okay, now see, attention here please. Here, okay. Now we have to write the perimeter. What is perimeter?
Sir, it's to add all add the numbers that have the same letter, and then when we come, we do.
Give chance to others also. Please let other participate. Yeah, you. What is perimeter? Again, please. The length. That is good. You started from here, move here, and come here, here. So the total distance or the total length which you covered starting from some point and come back to that point. So this is called perimeter. Like you can see, if someone have trouble, the perimeter of this starting from here, you move here, 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 and come back. What is the total length or what is the total distance you have covered is your perimeter. Understand? Now look here. The the length of this is how much? 3. So suppose P represent perimeter. So this is 3. This is how much? B. This is how much? This is how much? Great. This is how much? Plus B. And 1 minute. It is also? Okay. So plus B again. And this is how much? 3. Now who will tell me how much is this? Okay. Can anyone please tell me what is the length of this? This is somehow tricky one.
So this is 3, then this 3 and this 3.
Look here. Can you observe this length is exactly this plus this plus this? You can observe, because bring this, look here. Bring this portion up here, this will complete a rectangle. And the rectangle, the opposite sides are equal. So actually this length is the sum of this, this and this. So it is 3 plus 2b.
3, 4.
3 plus b.
The 3 will be 4 times. Yeah.
Okay. So now how much is 3? 1, 2, 3, 4. So 3 multiplied by 4. And we are doing the same. We are bringing 3 together actually. And how much time b? 1, 2, 3, 4, 5, 6.
Your answer will be 12 plus 6b.
So this is 12 plus 6b and we have done. Understand or not? I think
So this thing we took, like, for how many?
you can exactly see like other problems.
I think we took it very much, but from how many months ago?
Okay. Now let me do which one you like to do in problem 2. Anyone please tell me? Can anyone suggest me? Is like the D part is very easy. 2x plus 3 plus 2x plus 3 and y minus 2 plus y minus 2. Let me do it.
I need the coolest. I mean, all of them are easy, but for these is the coolest.
2x plus 3 and y minus 2. What is this shape?
Rectangle.
What is this shape exactly? Rectangle. Okay. If this side is 2x plus 3, then what is this side?
2 is for 3.
The same?
Yeah.
Opposite side in rectangle are equal. And this is y minus 2, then how much is this? Y minus 2. Now simply add it. So perimeter is equal to 2x plus 3 plus, tell me, y minus 2. Great. Okay, now combine like terms. How much x? 2x plus 2x, 4x. First write variable, then at the end write. This is like the general observation. There is no problem, but mostly mathematician write variable first, at the end they write constants. So how much time y? Plus y and y plus 2 plus 3 and minus 2 minus 2 minus 4 plus 3 minus 1. Understand this? So this is the perimeter and this is your final answer. Okay, Murtaza, the next one is also easy. You can observe pipe m plus 3n. Just see it. Pipe m plus 3n plus 4m. Okay, and now see the total height. The total height is again 3n. Understand? And you can see 4m, but the above portion, this one is 1m. So it is pipe m. It is exactly the perimeter is exactly the rectangle perimeter. So if you remove some part from a rectangle, the perimeter does not change. And this is the same problem which is it asking in the next problem. See in the next problem. The next problem. Okay, let me do it properly. Anyone have problem? No one? I think this part is much easier than the previous chapter.
Yeah.
You are happy right now? You did not understand?
No, I'm sorry, but the last chapter and this are the same.
This and last chapter is the same?
No, he made the 3
Because he is just looking to the triangles and rectangles, but you don't see what is written, what is asking in that portion and what is asking in this, what is asked in this portion. Okay, let me do the problem 3. Point P. Okay, this is a rectangle and this one is pipe P. P is any variable or any unknown. This is 3P. And if this is pipe P, then how much is this? And okay. Okay, let me ask you a very good question. If P is not a fixed number, this P is suppose not a fixed number, then this pi P like this represent how many triangles? If P is not a fixed number, how many triangles are these? Is it one triangle?
2 triangles, I think. 3.
How many triangles?
2, no.
Rectangle, sorry. I'm confusing the words. Okay, this is a rectangle actually, not a triangle. But if P is not a pix, then what is?
4, I think.
Okay. Suppose you set P equal to 1. Then it will give you this rectangle. 5, 5, 3, and 3. And suppose P is 2. So it will give you this rectangle. This is 10, 10, and 6. And if P is 4, it will give you another rectangle. If P is 5, it will give you another rectangle. So actually, this is not a single rectangle. If you will fix P, it is a single rectangle. But if you will allow P to be a variable, then it gave you infinite many rectangles. So it is actually the combination of infinite many rectangles, not a single rectangle. But it is hidden inside. Who understand this point? You understand? You did not understand. Look here. Abdul Hadi, suppose P is not fixed. Okay, P is keep on varying. So in one particular case, P is equal to 1. When P equal to 1, then pi P is how much?
5.
Huh?
10.
Pi P means 5 multiplied it by P. So 5 multiplied it by 1 is how much? 5. So and 3P will become equal to 3. So this will give you this rectangle. Now you change P and P equal to 2 because P is keep on changing. I told you it's a variable, not a fixed number. So when you will plug P equal to 2, so pi P will become 5 multiplied it by 2 and it will become 10, and 3P will become 3 multiplied it by 2 and it will become 6. So it will give you this rectangle. Right now this rectangle is different from this rectangle. But I told you in advance, P is not a fixed number. So P is keep on changing. So now in the next case, P may be 3. In the next case, P may be 4, 5, 6, 7, and so many others. So when you will change P, every time you will get a new rectangle. Now understand? So this thing, if P is not a fixed number, this is a large combination, infinite many combinations of rectangle, not a single rectangle. I think it's somehow a critical point. If you understand, it's good. If you did not understand, no worry. Understand?
Yes, sir. Yeah.
Abdullah Sakir, you got this point? So sometimes like the thing seem to be very simple, but inside that there is a whole universe. So you can see inside this one rectangle, there is infinite many rectangle, and you can see and you can draw it. Okay, now it is asking that suppose, okay, let me draw the, let me calculate the perimeter of this. This P is capital, this is small, okay, capital P per perimeter, small p is the variable. So what is the perimeter? 5P.
16. 5P plus 3P plus 6.
It's 10P plus 6P, 16P. Understand? Now what is done? It is separated a small rectangle, a small square from this one. Okay, this has been separated, like it has been separated with the help of scissor. Now this is the final shape. Understand? Okay, tell me what will happen to the perimeter?
Nothing.
That's correct. But it seemed to be like, normally we think like we have to subtract this perimeter, but you will see this is 5P, this is 3P. Right now this length is totally this plus this, which is again 5P. And this height is this plus this, which is again 3P. You understand? So there is no effect to perimeter. If you will cut some portion, or like square type of portion or rectangular type, and you might have seen in the above problem I told you before.
You know what? That was actually the first question of my life, which had like an answer of nothing, and the nothing was correct. You know, you asked me like what would be the change in the perimeter, and I said nothing, and that was correct. So
Okay.
that's the first time nothing answer was correct.
Yeah. So the perimeter does not change. Write down. I think you're not writing. You're not writing in the notebook today. Well, you have got the same continuation. Write down this in the notebook.
I learned this. I learned. Yeah.
Now again,
Sure, like I do.
the perimeter is 16p, hence no changes to perimeter. Abdul Hadi, what is time? 10:56. We have enough time to complete. Okay, now we have 8 different sticks. Okay, these are 8 different sticks. This is stick with length x plus 2. This is a stick with length x plus 5. I'm sorry. Let me listen again. Okay, this is a stick whose length is x plus 2. We don't know what is x. X is something, okay, unknown.
Yeah. I know.
And this is a stick whose length is x plus 5. It means this one stick is greater than in length than the previous one. This one stick have again x plus 2 length. This one have, and it is mentioned in the time.
Imagine a world where X was not
Okay, now we have to use 7 sticks out of 8 sticks, and we have to form an equilateral triangle with the help of those sticks. First of all, tell me what is equilateral triangle?
triangles. Which sides are equal again?
Whose all sides are equal in length. Understand? It's good. Now, how many sides are there in a triangle? 3 sides. Okay, and total sticks are how much? 8, but we have to use 7 sticks. Okay, so if you will put two sticks in each side, so it will be equal to 6 sticks, but you have to use 7 sticks. It means you have to use in one side 3 sticks, and maybe in the other 2 sides 2 sticks. Okay, so but we know in equilateral triangle all sides are equal. So suppose I want to use 3 sticks, okay, and I want to form one side, and with the help of 2 other sticks I want to form another 2 sides, yeah, equal length. So now if you will combine 3 sticks, okay, even if they are smaller, they will become larger. So we have to use smaller and smaller in the case where we are using 3 sticks. You understand this phenomena? Again, we have 7 sticks. We have to use 3 sticks in one side and two on other sides. Okay, in one side we have to use 3 sticks. Okay, so this is like an intuition. We will use smaller sticks in the side where we use 3 sticks. So tell me, in these sticks, which one are smaller? X plus 2 and x plus 2 are the most smaller. After this, the most smaller one is x plus 3. Yeah, go. So see, x plus 2 plus x plus 2 plus x plus 3. What is the answer of this?
It's a 3x plus
7. Now you have used already this one, and this one, and right now you have 5 more sticks. You have to use, right now you have to use 2 and 2, okay, but in a way such that the sum of 2 sticks is always right now 3x plus 7, because one side is 3x plus 7. You have to adjust all sides 3x plus 7. You can't do like, you cannot change this thing, because in equilateral triangles our sides are equal. So can anyone tell me, is there any 2 sticks whose length is this one? See it, observe it.
So can we use the previous one?
This one? No. When it is done, it is done. Abdul Hadi, you are understanding the problem? Okay, so in these 5 sticks, can you find out 2 sticks whose length is this much? Just try to find out it. I think it's not that difficult.
So I got it.
Yeah.
X plus 5 and 2x plus 2. No.
X plus 5, one is this, and 2x plus 2. Yeah, this one is great. One is x plus 5 plus
3x plus 7.
So it is 3x plus 7.
But if we don't know like the value of x, how can we say that 2x plus 2 equals x plus 5?
No, we don't know x, but we know x plus 2x is how much? It's a 3x.
Yeah.
We don't know x, but we have to equalize this and this. X is anyway, and now put x equal to 2. So this will become this much. And x equal to 3 problem right now. If the state expression are the same, so definitely if you will put any x, both are the same. Same means same.
Like 2 doesn't like, for getting to 7, the other digits which are 5 and 2, so 5 plus 2 is 7.
Yeah.
Now, before the 5 there's an x, but before the 1, like before the 2 there's a 2x, right?
Yeah.
Doesn't that make like any difference? Or 2x and an x?
My dear, you have to make this expression.
Yeah.
So we have choose this one. We say we have selected one, this one, and one, this one. And we got the expression. There is no confusion in this. Can you please repeat your problem? What is confusion in your mind?
So you know what? For example, let's say that the value of x is like 5. For example,
X equal to 5. Great.
so for the first case, we did x plus 2 plus x plus 2 plus x plus 3.
Yeah.
So I mean, whatever that was, it made it equal. We made it like, for example, we made it equal to 7. Okay. So, but in all of them, there was one x, right?
Yeah, yeah.
But if the value of x is something, but in this one we did 2x, right? So the value gets doubled. So,
Yeah.
and in the x plus.
But the result is the same. Look here. Plug here x equal to 5. So 5 plus 2 is how much? 7 plus 5.
Yeah.
And it is equal to this thing. So you can put here or you can put here. So put x equal to 5. 3 multiplied by 5, 15 plus 7, 22. Again 22. Put x equal to 100. Again you will get the same result. There is no problem in this. Yeah. It's okay right now? Okay. Now look here. You have to use any other two also.
X plus 4 and x plus 3. X plus 3 and plus 2 x plus 4.
Great. This and this one. X plus 3 and plus 2x plus 4. And this is will become 3x plus 7.